If you went to a computer lab in the 1980s or 1990s in your elementary school, you probably learned the Logo programming language. Today we'll talk about Logo, why it was so popular as an educational tool, and how it differed from other programming languages. Welcome to Kopec Explains Software, the podcast where we make computing intelligible.
This week, Dave, we're talking about Logo, which is a programming language for kids.
Yeah, and I know that you've been reading a little bit about the history of Logo. So when was Logo developed and who developed it?
Yep, it was developed in 1967 by three developers, Wally Feuerzig, Seymour Papert, and Cynthia Solomon. And it was developed in Cambridge, Massachusetts. The whole goal behind it was to give kids a chance to learn how to program in a really simple and kind of fun way.
Yeah, so you can almost think about Logo as the 1960s version of Roblox. I know Roblox is very popular. It's like a top 10 app on the App Store right now. And it's a way to help young people learn how to program. It's kind of a more fun programming environment than the type of programming environment that a typical software developer like me uses. And Logo was the same thing. So when people were learning Logo, they were learning how to manipulate a turtle on the screen, right?
Yeah, and actually the reason that is called a turtle, even though it could be any shape, it's the actual cursor, is that at the time there were a bunch of educational robots that kids could use that were called turtles. So it's kind of an homage to that. There's even a version of Logo that would be connected to one of these robots to have it move in a certain direction or pattern.
Yeah, I actually remember using Logo when I was in elementary school. When I was in elementary school in Connecticut, we moved around a lot, but we lived for a few years in Connecticut. They had Apple IIs in the computer lab. And we would go to the computer lab, load up Logo on the Apple IIs, and we experiment with some simple commands to move the turtle around. Just to talk more about what that looks like, that whole paradigm of the turtle is sometimes called turtle graphics. And you can actually get a module like Logo's turtle graphics in Python. So if you're interested in experimenting with it and you know Python, you can go try it out. Here's the idea. You basically have an XY plane and you have this turtle on the screen. And when the turtle moves, it leaves a line behind it. And so you give the turtle simple commands, like you say to the turtle, move forward 10 spaces. And then a line that's of length 10 in the units of the plane will then exist behind the turtle. And in some versions of Logo, you'll actually see the turtle be animated. So you'll see it move 10 forward. And then you tell the turtle to do something relative to its current position. So the turtle has now moved 10 positions forward, and you might tell it, turn right 90 degrees. So then you'll get a right angle if you then have the turtle move forward again. And so by telling the turtle to move forward, move backward, turn right, turn left, move some more, you can eventually draw a picture by a combination of these commands. And then if you wanted to do the same kind of picture again, you can actually combine those commands together into a simple subroutine. So that's just a piece of code that you want to be able to repeat. You want to be able to call it again when you want that code to happen again. And so then by building up chunks of code that do different little bits of the drawing, you can start to do more and more sophisticated pictures by just telling this turtle how to move in repeated ways. And that was really the beauty of Logo, is it gave something very tangible very quickly to the kids who are learning how to program. So you're saying to them, hey, you don't have to learn all this stuff before you can start drawing pictures. You just need to learn these really simple commands to start drawing pictures. And then we can take those simple commands and build them up into actual programs that have a little more sophistication to them. But getting started is as simple as writing forward 10 and having that turtle move forward and see a little line.
What programming language was Logo based on or connected to?
Yeah, I understand they had some inspiration from Lisp, and we did a previous episode on Lisp that I'll link to in the show notes, and I'll also link to the Wikipedia article on Logo because it has some good history there. But it really is not like learning Lisp. Lisp is a sophisticated programming language. Logo is really designed for kids. I mean, when I said earlier, it's as simple as writing forward 10, that's literally the syntax. You would actually type into your editor forward 10, and that's actually part of the programming language. And when you want to turn right, you literally write right 90 when you want to turn right 90 degrees. It's that simple. And there is more to it, of course. There's syntax for building those subroutines. There's syntax for repeating yourself. There's variables in the language, so you can actually store values in variables. It is a full programming language. Like, you technically could write a program that did just about anything in Logo. You wouldn't want to. It's really oriented around this idea of moving around the turtle. So you really would only want to use it for turtle graphics. But the syntax is so simple that it is approachable to a young child as young as 7 years old.
Would it be helpful for an adult who wants to learn how to program?
I don't think as much. I think that, and I have some experience in this space, I've actually built a programming language called CTurtle, which is inspired by Logo. It's not exactly the same as Logo, but it's a programming language for the Mac, and I'll put a link to it in the show notes. And I also really market it towards young people, because as an adult, I think you're going to quickly grow bored of the limitations of the language, whereas the limitations of the language are what make it so approachable to a child. So I think that for an adult, you're fine starting out with Python or JavaScript or some other modern language. But I really think that Logo or CTurtle is best served for children.
It's a great way for kids to kind of dip their toe in the water of programming.
Right. Logo or CTurtle is a first programming language. It's maybe you're going to spend 10 to 50 hours with this. And then if you really enjoyed it and you kind of took it to a point where you've done something semi-sophisticated, you might realize, I want to go further, and then you'll pick up Python or another programming language. Your programming career is not going to go forever in Logo as a kid. It's going to basically just be a starting point for you. And there's a lot of other programming languages in this space. We mentioned Roblox earlier. Another one I know from the 90s was called Carol the Robot. Maybe some people remember that. There's also, of course, Scratch, which is very popular and is more for building animations, and also takes some inspiration from Logo as well. But I think it was developed at MIT, and I'll put a link to that in the show notes as well. But it's also a great alternative to Logo. I mean, people are still developing logos today. So the original logo you mentioned was developed in the late 1960s, and then I mentioned it was very popular for teaching kids to program in the 80s and the early 90s. But there are many versions of Logo that are still around today, that are still being developed, that are still being advanced, and are still being used in classrooms. So it's absolutely an option. But maybe moving a turtle around the screen is not as exciting to a kid today as moving an actual animated character, as you can do in Scratch, or actually building your own 3D game, as you can do pretty easily in Roblox. So I could see how the appeal might have waned a little bit, but I think there's still a lot of kids getting a lot of value out of Logo and programs like CTurtle.
What skills does a student or a kid need to have to be ready to learn Logo?
Yeah, not that much. I was saying earlier, I think about 7 years old is kind of an appropriate age, because the skills that you need are basically some very basic arithmetic. So you need to be able to add integer numbers together. And you need to also be able to understand very little bit about angles. So enough that you can understand that, like, the bigger an angle is, the more something turns. And you have to have a little bit of language skills. So you should be at the point that you're writing. So you can understand words like forward, left. That's all you really need to get started. Now, the abstract thinking skills you need to take it further and be able to build subroutines go a little bit further than that. And so I remember myself when I was 7, 8 years old and being introduced to this, I don't think I was quite ready really for subroutines. But I was able to build programs, but just not something that really was very modularized or reusable or really that sophisticated. But just getting started, absolutely. All you need is some really basic arithmetic, a basic understanding of angles, not to the level that you might get in a geometry class in school, just to the point that you understand that what it means to turn. And then a little bit of language skills, just being able to understand commands. And I think just seeing that as a young person, seeing like, hey, I give this command and the computer does the same thing perfectly every single time, is really powerful. I think that's really, to understand the repeatability of the math, the repeatability of the computations, is on its own very powerful for a young person.
How can folks get Logo now?
Yeah, so I'll put a link to Sea Turtle in the show notes. Again, it's not exactly Logo, it's my spin on it, but it's only available for the Mac. But there's plenty of free implementations for the Mac, for Windows, for Linux. If you even just go on an iPad today and you search Logo on the App Store, you'll find some free options. I've tried a few of them myself. There's no single one I would recommend. I'd recommend Sea Turtle, of course, for the Mac. So I'm not going to go specify an exact one. But I think there's many good options. And, some young people might grow out of it very quickly. You might show it to them and they might also say, wow, this is too limited. And it was just, it's just a starting point. Logo is definitely not an ending point. And it might be that you try out Logo and you also try out Roblox and you also try out Scratch and you see which of them really appeals to them. And it's possible none of them appeal to them. And this might be a good test on whether or not, even if they're a little bit older, if they're more like 10 years old and they start to offer programming electives in their middle school. If you try this out and they're really I don't see why this is interesting at all, maybe you realize, that that's not the right elective for them. So it might be a good little test. I don't really believe in this concept that everybody needs to learn how to program. That's kind of a big thing in education right now, is that we should have programming education for absolutely everybody. I think some people are just not interested, and there's a lot of careers where it's not relevant. Is it a good skill set to have? Definitely. I mean, is it useful in many careers, even ones that are not exactly being software developers? Absolutely. It's great to be able to automate things. It's great to be able to tell a machine what to do so you can reduce the amount of work that a human has to do. But I don't think it's an essential skill set that every single person needs to have. And I think this is a good way to test it out. See if this is something that, your child is really interested in pursuing. All right, thanks for listening to us this week. Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPECEXPLAINS.
Thanks for listening, and we'll see you next week.
Bye.